When people imagine alien civilizations, they almost always picture space, distant planets, faraway stars, the vast physical scale of the cosmos. But there's another dimension just as vast that rarely gets the same attention: time. The universe is roughly 13.8 billion years old, and Earth itself has been around for about 4.5 billion of those years. Plenty of room, in principle, for something to have come and gone long before we arrived on the scene. Could an entirely different technological species have existed on Earth, risen and vanished, hundreds of millions of years before we ever showed up? Could their remains, or the remains of whatever they built, be buried right beneath our feet at this very moment? It sounds like science fiction, but it's actually a serious scientific question with a name: the Silurian Hypothesis. So what does the evidence actually say, and what would it mean for us if the answer turned out to be yes? Life has existed on Earth for roughly 4 billion years, but for most of that span, it was nothing more complex than single-celled organisms. Then, around 540 million years ago, the Cambrian explosion arrived, and within a geological blink, probably somewhere between 13 and 25 million years, astonishingly fast by evolutionary standards, complex animal life diversified explosively. Nearly every major body plan alive today, from hard shells to complex eyes to jointed limbs, has roots tracing back to this single, relatively narrow window. That leaves an enormous stretch of time, hundreds of millions of years, during which some other intelligent, technological species could theoretically have emerged, built something, and disappeared again, long before humans ever existed. Where would we even begin looking for evidence like that? And realistically, what could we actually expect to find? The frustrating part is that we only have one real example of a technological civilization to study, and it's ourselves. Anatomically modern humans emerged roughly 300,000 years ago, living for most of that time as small, scattered groups of hunter-gatherers slowly spreading across the planet. Progress was almost imperceptibly slow, generation after generation, with occasional local bursts of complexity that mostly didn't stick. Then, only around 10,000 years ago, the agricultural revolution changed everything, unlocking population growth and technological change at a pace nothing before it had come close to matching. We stopped being just another clever animal with tools and started reshaping the actual surface of the planet, clearing forests, building cities, raising monuments to our gods. And then, a mere 300 years ago, industrialization hit, and our numbers and our impact on the planet both exploded again, this time exponentially. Put in percentages, our entire 300,000-year history breaks down strangely. Roughly 97% of it was spent as hunter-gatherers, about 2.9% as farmers, and a mere 0.1% as industrialists. Nearly everything most people would recognize as human history, writing, empires, religion as we know it, science, industry, fits into that final sliver, a rounding error compared to the hundreds of thousands of years that came before it. We are, on any geological timescale, an almost impossibly new arrival. And on those timescales, even the toughest, most durable things eventually lose their integrity. The oldest continuously exposed, large-scale land surface on Earth today, the Negev Desert, is only about 1.8 million years old. Everything older than that has long since been crushed to dust, buried, or swallowed by ice and ocean. Mountain ranges rise and erode away entirely within tens of millions of years. Whole ocean basins open and close over similar timescales, recycling the seafloor back into the planet's interior. Our current era, the Anthropocene, will eventually compress down into a geological layer only a few centimeters thick, once enough time has passed. So if there really were aliens before us, and they went through similarly staged phases of development, what would actually be left of them today? What can looking honestly at ourselves teach us about what an indigenous alien might have looked like, or left behind? We actually do know, with real confidence, that hunter-gatherer level aliens existed in the last few million years, just not aliens in the extraterrestrial sense. Homo erectus, the Neanderthals, the Denisovans, and probably several other hominin species we haven't even identified yet, or have lost to time entirely, all qualify. The Denisovans are a particularly good illustration of just how thin the evidence trail can get, even for a real, confirmed lineage. The entire species was first identified in 2010 from a single, tiny finger bone fragment and a couple of teeth found in a Siberian cave. And to this day, we still don't have anything resembling a complete skeleton. Almost everything we know about how Denisovans looked and lived comes from DNA analysis rather than actual fossils. If a species that genuinely existed, interbred with our own ancestors, and left detectable genetic traces in millions of people alive today, can still be represented by essentially a handful of bone fragments, it's a sobering reminder of how much could simply be missing entirely. They left behind fragments, bone, tools, weapons, even early art. Given how long they existed and how little of them actually survived, despite living relatively recently in geological terms, it's not hard to imagine other, fully separate, intelligent lineages that also talked, used tools and fire, and had culture, quietly existing and vanishing without us ever hearing about them. For most of the last 2 million years, hominins overwhelmingly lived at the hunter-gatherer stage. If a hypothetical alien lineage never advanced beyond that same technological level, hundreds of distinct species or cultures could plausibly have come and gone without leaving a single detectable trace. Their remains lost first to biology, then to geology. In the worst case, a hunter-gatherer level civilization could vanish so completely that a mere few thousand years later, nothing recoverable remains at all. Fossilization itself doesn't help much either. It's an extraordinarily unlikely process to begin with. For an organism to become a fossil at all, it generally needs to be buried quickly, in the right kind of sediment, away from oxygen and scavengers, and then survive millions of years of geological upheaval without being crushed, melted, or eroded away entirely. The rare sites where conditions line up well enough to preserve unusually detailed fossils even have their own name, Lagerstätten, and they're famous specifically because they're so exceptional. Across any given 100,000-year stretch of ordinary Earth history, only a small handful of genuinely good fossils tend to form at all. We could easily be missing fossils of exactly this kind of civilization, and even if we found one, we might have no reliable way to recognize it as evidence of intelligence at all. A broken hominin-like bone doesn't come with a label attached, explaining whether its owner used language, told stories, or built anything at all. Agricultural and empire-building societies leave considerably more behind. Farming let ancient human civilizations specialize, developing writing, navigation, architecture, and organized government. And over thousands of years, city-states grew into kingdoms and empires, some persisting for a very long time before eventually collapsing. Rome controlled a territory stretching across 3 continents for roughly 5 centuries. Various Chinese dynasties maintained continuous written records and monumental construction projects across more than 2,000 years. Many of the structures and monuments they built are still standing today, and their outlines will likely remain detectable to future archaeologists for a few more thousand years at least. The pyramids, for instance, are such massive piles of limestone that they'll plausibly still be recognizable hundreds of thousands of years from now. Because agricultural and imperial societies supported so many more people than hunter-gatherer bands ever could, we'd expect a correspondingly larger number of detectable fossils and artifacts, potentially lasting a few million years before finally vanishing. That actually lets us say something with real confidence. No agricultural or empire-level alien civilization existed anywhere on Earth within roughly the last few million years, because if one had, we would almost certainly have found physical evidence of it by now. That still leaves an enormous open window, though, hundreds of millions of years stretching all the way back to the emergence of complex life during which we genuinely couldn't rule anything out. If an alien society existed at a pre-industrial level comparable to, say, ancient Rome or ancient China, it likely would have vanished almost entirely without a trace. Their tools, even advanced metal ones, would have simply corroded away over deep enough time. Any canals they dug, forests they cleared, or cities they built would become essentially indistinguishable from ordinary natural landscape features. It's entirely possible to imagine, purely as a thought experiment, an ancient empire of cephalopods, thriving in wood and stone cities built across ancient swamps and lakes, their engineers flooding land to build wetland settlements. their poets reciting verse in some now unimaginable language, built from shifting colors instead of sound. Their historians recording events not in written script, but in elaborate, rehearsed patterns of bioluminescent skin display, passed down and performed from one generation of storytellers to the next. Maybe such a civilization simply never industrialized. Maybe it was too stable, not inventive enough under the circumstances, or simply never got the chance, snuffed out early by an asteroid impact, an epidemic, or an ice age. Its temples ground to dust as its soft, unfossilizable bodies quietly rotted away, leaving nothing behind but soft tissue that decomposes long before any mineral could ever replace it, unlike the hard shells and bones that make good fossils in the first place. We currently have absolutely no evidence, one way or the other, that anything like this ever existed. But within a few million years, virtually any civilization's achievements at that technological stage would plausibly dissolve into nothing detectable regardless. What about a civilization like ours, genuinely industrial? Imagine humanity vanished abruptly tomorrow, wiped out by a pandemic, cosmic radiation, or some comparable sudden catastrophe. What would actually remain? Our current impact on the planet is orders of magnitude larger than anything our hunter-gatherer or early agricultural ancestors ever managed. The fossil record left behind would show a dramatic extinction event across wild species, alongside a sudden explosion of fossils from the specific animals we've spread everywhere alongside us. Rats, cows, pigs, chickens, animals that together already outweigh, by some estimates, the combined mass of every wild land mammal and bird on Earth. Like the monuments of earlier human eras, our skyscrapers, roads, and hard drives would mostly crumble into unrecognizable rubble within a few thousand years. But because there are currently so many of us, spread across essentially the entire planet, unmistakable hints of our existence would likely persist for a few million years afterward regardless. And several specific byproducts of industrial civilization might last far longer than that, potentially for hundreds of millions of years. The massive quantities of artificial fertilizer we produce have measurably redirected the planet's entire natural nitrogen cycle, roughly doubling the amount of reactive nitrogen entering ecosystems compared to natural background levels. Mining metals and rare earth elements leaves long-lasting geological scars and depletes deposits that took ages to form naturally. We've saturated the oceans with plastic waste that settles onto the seafloor and could persist, essentially unchanged. For hundreds of millions of years, microplastics have already been found in ocean sediment layers on every continent's coastline, including areas as remote as deep Arctic ice cores. There are unnatural concentrations of radioactive elements and their decay products, substances that essentially don't occur in nature outside of laboratories or nuclear weapons. The radioactive fallout from 20th century nuclear testing is already detectable as a thin, distinct layer in soil and ice cores worldwide, precise enough that scientists have proposed using it to formally mark the start of the Anthropocene epoch. And over our comparatively brief industrial history, we've already meaningfully shifted the proportion of carbon dioxide in the atmosphere by burning enormous quantities of fossil fuel, measurably increasing ocean acidity along the way. It's entirely plausible we've already left a permanent mark on the geological record. So far, though, we haven't found any equivalent trace of an industrial alien civilization anywhere in Earth's deep past. No strange chemical layers, no oddly displaced elements, no radioactive signature hinting at some ancient nuclear conflict. We're actually pretty good at detecting genuinely unusual geological moments when they exist. The boundary marking the extinction of the dinosaurs 66 million years ago contains an unmistakable spike of iridium, an element rare on Earth's surface but common in asteroids, which is exactly how scientists first confirmed an asteroid impact was responsible. If an ancient industrial society had left something comparably distinctive, geologists sometimes use the term technofossil for exactly this kind of artificial signature, things like plastic fused with rock and sediment, sometimes called plastiglomerate, which humans have already started producing today. It's the sort of thing that plausibly could be found if it existed. We do see genuine mass extinctions and dramatic shifts throughout the fossil record, but nothing suggesting they weren't caused by ordinary natural processes. And this actually reveals a strange, almost paradoxical problem hidden inside the whole question. If an industrial society stresses its environment badly enough to cause its own collapse, it likely won't last very long, but the resulting damage might at least leave behind a detectable signature. If instead that same civilization somehow becomes genuinely sustainable, it might barely leave an imprint on the geological record at all. In other words, if past industrial civilizations existed and managed to become sustainable before eventually fading away for other reasons, we may have essentially no realistic chance of ever detecting them today. It's a genuinely uncomfortable asymmetry, the very outcome we'd most want for any civilization, our own included. Long-term sustainability, a light footprint, minimal permanent damage to the surrounding environment, is also the outcome that would make that civilization hardest to ever find evidence of again, whether we're searching for someone else's past or leaving a legacy of our own. Over hundreds of millions of years, even a real industrial signature could plausibly become so faint and subtle that it gets misread as an entirely natural process. Even a hypothetical alien industrial civilization from 200 million years ago that lasted 300 times longer than human industrial civilization has so far, genuinely dominant for 100,000 years, might still be nearly impossible to positively identify in the geological record today. All of this, to be clear, remains firmly in the territory of speculation. It's worth being honest about that, rather than letting imagination quietly convince us we know something about our own blind spots that we actually don't. Simply assuming something happened, purely because we currently lack direct evidence against it, is a genuine trap worth actively avoiding. There's an interesting connection here to a much more famous puzzle, the Fermi paradox. The observation that if intelligent life is common in the universe, we'd expect to see some sign of it by now, and yet we don't. The Silurian hypothesis is really the same question turned inward, applied to our own planet's history instead of the wider galaxy. If intelligent, technological life could plausibly arise more than once, given enough time, why does the geological record look, as far as we can currently tell, exactly like a planet that's only ever had one? So for now, at least, when we look honestly across the vastness of deep time, it appears just as empty of intelligent civilizations as the vastness of space does. Maybe we really are alone, and always have been. Maybe convincing evidence of something else is still out there, waiting to be found. Nobody currently knows either way. But there's one important takeaway buried inside all of this regardless. The continuation of our own civilization isn't actually guaranteed by anything. Every previous chapter of Earth's history, the trilobites, the dinosaurs, entire branches of our own hominin family tree, eventually ended, whether through their own success running out of room to expand into external catastrophe or something in between. There's no law of nature that exempts us from that same pattern simply because we've built cities and telescopes. If we aren't careful with what we've built, we could just as easily disappear completely, leaving behind nothing but a strange, thin layer in the rock for whoever or whatever eventually comes looking. And if the Silurian hypothesis teaches us anything useful in the meantime, it's a certain kind of humility, about how much of deep history is genuinely unknowable, about how thin the line really is between definitely didn't happen and we simply have no way of telling, and about how easy it would be for an entire chapter of intelligent life, ours included, to eventually become just another quiet, ambiguous smear in someone else's rock core. Here's hoping that a few million years from now, there isn't some other civilization out there quietly studying the geological record of us, wondering, the way we do now, whether they were ever really alone.